Hi, my name is Yutong Yi. I'm from Group 6, and our project stimulates a Bluetooth low energy environment using NFT and apply machine learning to classify transmitting device based on their signal characteristic. So we created a virtual testbed with three BLE NOT. Um, So this NOT use LRWPN to emulate BLE communications, and each transmission's signal strength and location are recorded over 10 seconds. The data is saved into a CSV file. Once the simulation complete, we launch a machine learning pipeline via BLE predictor.py, which is the file here. And this will train a model to identify which knot send the transmission based on the RSSI and spatial feature. This end-to-end pipeline allows us to test fingerprint technique before deploy them in real-world BLE environment. So first, in the BLE simulation files, we import NS3 Python modules and the standard Python library. And on the top, um, we imported CSV used for the data log sub-process that run the machine learning script after the simulation, which is the sub-process here. And then we create the three BLE node to stimulate signal transmission. Um, and then we configure the BLE like communication using the LRWPAN. Um, that sets the realistic propagation models for signal degradation and delay. Um, and then we assign a fixed position for each of the BLE node to stimulate spatial separation. It helps to identify um, the signal strength based on their distance. So here we try to identify the position for knot 0 and then knot 1, knot 2. Um, And then we have a function called log BLE RSSI. This function log stimulate the signal strength data per knot every seconds into a CSV file for machine learning. And then we schedule the logging function to run every seconds during the 10-second simulation. So this is the follow function here. And then we started the NS3 simulation and run it for 10 seconds. After the simulation, it will call the machine learning script to analyze the BLE RSSS log.csv file generated from the script. And then I'm gonna move on to the BLE predictor.py file. So in this file, we imported two on the top for loading data, speeding data set, building a classifier, and generating evaluation metrics. And then we load the RSS logs, which is the read-in function here. So we will read the BLE RSSI logs.csv file that we generated from the simulation.py. And then we here in the function here, we split the data into training, testing set, and we train the data using a random forest classifier here. And then um, we try to make prediction and print a classification report that will show the precision and accuracy. That is the function here. So this project is built using the GitHub.io, and then we build the NS3 that customize the simulation code using CMake, and this is we build the how we build the bindings with CMake files, and then this, in conclusion, like this project demonstrated a end-to-end system that can combine network simulation using the BLE simulation.py with machine learning, which is the MLBLE predict.py, to identify BLE devices based on signal characteristics using the NF3 while we stimulate realistic BLE communication. We configurable hardware imperfection, and we extracted the signal feature like RSSI and the spatial position. These are then classified using a trained random forest model to accurately determine the transmitting device. This module framework provides a test bed for radio fingerprinting research and can be extended to include more devices, advanced features, and real-world data. Thank you so much.